Hi my friends, let's model this part, step valve body, which has some threads all over. It is made from bronze, and we can take a look at the part. As you can see, it has also a conical internal volume and some steps here because it is used as a valve with these steps. The drawing is here. You can see it is not so complicated. We can start to model it. We start with this frontal face with dimensions here. This was made by me in 2010. Let's start with this front part and then we'll see what is the procedure. The plane is this one, XY, and we start with a circle with a diameter of 50, another one with a radius of 50, and the last radius 41. Then we draw some lines from this circle to the center and again to the same circle. We project the vertical, which is the axis Y, and we make all of them as construction lines. The angles for these two are 35 degrees, sexagesimal degrees, of course. Then we draw a line from a point of the circle. We continue with an arc of 180 degrees and parallel back to the circle. This is parallel, and the distance is 11. The thickness is 12. And we have a first element here. In order to place this dimension of 69, you recognize 35 degrees, 11, 12, and in order to create this dimension we have to draw a small line here, perpendicular on this line from the center to the circle and perpendicular as you can see. To outside, when we see this icon, we agree. 69. Okay, now you see fully constrained is this sketch. We mirror these three entities, lines and arc, about this vertical axis, as you can see. Now we extend this end, this line to the other circle, and we trim these two arcs and these two, and also this and this. These points are not important. They are obsolete. Good. Now radius 8, in order to draw this horizontal here and this vertical to the circle with a radius of 5. Okay, fillet 8 between these two and these two. Align from here, keep pressed the mouse button to go horizontal, and then again press the button and a tangent to this point. This radius is 5. Good. Something is not dimensioned. You see, this is not vertical. So we apply vertical to this line. Still, there is a dimension missing. Let's see which one. Apply a tangency. Yes, now it's fully constrained. We mirror again these three entities about the same axis. Apply. Now we apply radius 5 here, and as you can see, at an angle of 12 degrees are two channels which are reflected also here, and another one on the center. Remember dimensions 2, 1, the distance is 2, which means that half of the circle is here about. Fillet 5 between these two and these two entities. A circle somewhere here with a radius of 2. Another one is here, equal, and another one in the middle. All of them are equal. So I apply the proper constraint. Lines, construction to the center and back. This is not necessary because this point, this center is on this line. The other is at 12 degrees. 12. Okay, trim. Half of circles, then split. Only this arc. Then we make not visible all these 3 entities. Construction not visible, and fillet of 1. This is one, another, and this. Now we have to mirror these 2 channels about this axis. We select everything inside this rectangle, and I keep Control key pressed to eliminate these 2 arcs because they are part of this arc. Then mirror about the vertical axis. Apply. Done. Here is the former arc, which must be splitted as well in 4 points. Why? To make this construction arcs, as you can see. 2 dimensions needed. Which are they? Oh, I didn't place this point on this line. Let me make coincident this, and you see also the mirrored one is in place. We still have a dimension missing. Apply. It seems to be this one. Remove. Done. Maybe this is not on the circle. It is on the vertical but not on the arc. Coincident this point with this arc. Now we have fully constrained. Home, finish sketch, F6, and extrude. Now be very careful. We select all 3 areas. The extrusion is 10 millimeters, which is an implicit value. This is 10, but in the other direction. Plus, now as you can see, there is a channel here to remain 5 millimeters the mid volume. So we have to make an extrusion here. We select this, we apply cut, and the distance is 10 minus 5 divided by 2. We write expressions because we want to use dimensions in the drawing, not inventions from our heads. Okay. On the other side, as you can see in the drawing, there are the same diameter 50 and radius 41, the same up and bottom frontiers, but 45 and 45 are the limits, not like on the other face where is no limit. Good. Sketch, project these two arcs, then align from the first arc to the center and to the same arc. Excuse me, trim this. I make all this minus the 2, constrain construction lines, this one not. What is this? We make all of them construction lines, and these are not construction. Good. Split these lines, apply 45 degrees, but let me project the y-axis as construction line, dimension 45, and now you see something interesting. They are not collinear. Yes, when you split you lose collinearity and some other things. You must be very careful. I apply collinear between these two because I want the line to go to the center, and I make this construction. Then I draw two arcs. One is this and the other is this one. Oh, once again, the other is this one. Two dimensions needed. They are not, or one of them is not where it must be. Let's see. Oh, it was not finished, so I apply extend. The other end is good, and this point must be here. The other missing constraint is concentricity between this arc and this arc. And now fully constrained. As you can see here, radius 5 to all the 4 corners, fillet 5, 1, 2, 3, 4. Finish sketch, extrude this face, cut the same dimension because it is symmetrical in this aspect. F6. Okay, we continue with this conical volume, diameter of 36, 10 degrees, and here is a horizontal line to the 12 millimeters, and then to radius 4 and 2. Let's draw these lines, arcs. F7. We draw a line from this very point to the right, then an arc of 4 and another one of 2, which must continue not horizontal, so here to this point and back to the start. Oh, too large are these arcs. 4 and 2. Dimension from here to the center point is 12, and the angle is 10 divided by 2. The length is 53 from the face, so we apply from here to this 53. This must be coincident with this. It is. The diameter here, let me make this center line, and then the diameter of 36. There is a dimension missing here, maybe this or this or this. Now let's see, apply, remove. There is not tangent something here. Look, this is not tangent. Now it is fully constrained. Finish sketch, revolve, adding a new volume. Then we create this vertical volume of revolution. You see it here, which has its dimensions here: diameter of 36, 28, thread 40 and 8, and 4, 2 are some other dimensions of the clearance. Let's create this new volume. It is placed at 33. You see here, 33 from the front. Okay. Then we use this plane, F7, and we draw lines from here to somewhere down. Now 108 degrees. Here and back to the start point. This line must contain this point. Good. This is, let me place the dimensions before, 33. Now I make this line a center line to place the other dimensions. 36, as I said, 28, 40 is this line, 8 this one, and the total is 75. You see here, this one is 75. What is the diameter of this? Well, all we have is this dimension, but we know what is this. I told you about this in my former tutorial, but I'll tell you again. If you write fast group, 8 letters, FAST group .row, and you apply enter, you come to my site. Yes, this is the moment when I retired from my job in the Polytechnica with all my colleagues. So go here to the tutorials, and you see that you have thread for pipes, the directory, the file, the Excel file with the table in Inventor. download it and look at it. What you see, these are dimensions. Where are they? And I select BSP pipe, gas 3/4 is this line, and for an external shaft you have here the dimension, yes, 26,441 millimeters. Copy this, and we don't save the table. We'll place it in our drawing, in our model. But first I want to show you the other index table, the other Excel file, which can be downloaded by you to see all the tutorials from 1 to 163, and when I finish this 164, you'll find it here. You can use links to go to that all tutorials. So this diameter in millimeters must be placed here. Dimension activated, diameter, paste. 26,441. Okay. One dimension needed. What is that dimension? We'll see immediately. The radius. The radius of this clearance. Dimension of 2. Finish sketch. Revolve. Everything is in place. Okay. We continue with the hexagon. 36 and 12 from the 40. Yes. So we turn the part, we select the face, F7, I rotate this polygon, center, and this is the first presentation. This must be horizontal, and the dimension is 36. Finish sketch, extrude, the other direction, join 12. We have to chamfer this corner because we have this 30 degrees. How to do this? Let me place it back. How to do this? Well, we create a plane which contains this point and is parallel with this. This is the plane for a sketch. F7. A sketch which starts with a line starting from here and close. Then I project geometry this point, and I make coincident this face, this side with the point. The angle is 30. Fully constrained. Revolve this small triangle about the y-axis. Cut. Okay, you see a nice chamfer. Now I will use this plane for creating this revolving volume, which has the same thread like here. We know the dimension, which is 15. The length is 15 and the total dimension is here 85. Diameters are that one 26,441, you know it, and 20. Let's create this new revolving volume. F7, line, up, left, a short line, and an arc to the other end, another arc, another short line, horizontal, and close. This line is center line. Its midpoint is to be placed here. These two are collinear. These two are equal, and also the arcs with the same radius. Now dimensions. This is 85. This is 15. The radius is 3, this one. This diameter is for gas fillet of 3/4, 26.441. And this is 20. And now fully constrained. Finish sketch, revolve. Okay, all over. The plane is no more necessary to be visible. Now we create the inside volumes, and we start with this one, conical, 10 degrees, 33, 12 millimeters for this face, clearance here of 3 millimeters, radius 1.5, any of these two is okay, but not both. 42.5 is the diameter, external diameter of this. You see the dimension here, 12. The other 12 we used already to create this small cylinder, short cylinder. Okay, the angle is from parallelism with this. So we use this plane, F7, and we draw lines. We start from here because we can select the midpoint. Then to the left, up, radius, and back to the center, which is around this point, and back. I hope that everything is well. 1.5. This must be a center line. I project as construction this generator, no construction anymore, parallel these two, a diameter of you see, I wait to obtain this icon. To place 42.5 and then 33. From the center point, or that line is 12. Good, fully constrained. Revolve, cut, select profile. This is the profile. Okay, now we have that conical internal hollow, and we can place here the gas fillet, 1.25 inches. We can do this without knowing the millimeter diameter. Is placed here with this center and threaded ISO pipe. The diameter we select from here. We know a thing. I know a thing. This is 1 inch. 33 millimeters is the external diameter of a pipe with internal 1 inch. So not this, but this must be this is 1 1.25 inches, 1 1.25 inches pipe. We make it on a distance. The end must be flat, and the distance is 12, but minus the radius 1.5. Yes, to be in the middle of the clearance with the end of this distance hole, threaded hole. Yes, this is a clearance, and the hole ends there. Let me apply this 1.5 chamfer, which is also in the new hole, and at the end of this other threads. So I apply 1.5 to these three shafts and this hole, all the same, F6. Now I apply threads on this shaft, ISO pipe threads. You see, if we place there this diameter, the thread is okay, selection is okay, plus this, which must be also ISO pipe thread, plus this ISO pipe threads. Okay, F6. Next internal hollow is this, a countersunk with diameters 15, 11 and depth 7, 22 on both ends. Here is not a hole but a slot. It comes after. So let's create this hole as a countersunk, not threaded, countersunk, which ends also flat on a distance of 22. I select the face, I select the center, and 11 is okay. 11. Tab. This is 22, the total depth. Tab. The other diameter is 15. Tab. And the depth of the countersunk is 7. That's all. Plus the same here on this center. Okay. Good. Now let's create the slot. The slot has dimensions here. It is placed on the vertical of 33, 4 between centers, and radius 2.5. We select this plane, F7, slot, center to center. The distance is 5. The radius is 2.5. Escape. Now I have to project geometry, this geometry, to place on the same vertical, I hope, these 2 points. No, it's horizontal. Horizontal, you see the horizontal line here? Autodesk must change this. I select this, and this is not horizontal but vertical. Now vertical, you see vertical, yes? Point with point are on the same vertical. I know I must rotate this to have vertical as a vertical, but when I have this situation, the vertical line near the cursor must be horizontal. Well, it needs time. Fully constrain, extrude, symmetrical, all the way. Cut. Yes, we don't add volume, we cut the part. Okay, F6. The last internal volume or hollow is this, with dimensions of 15, 7, 7, 5, to this plane. Now we don't have here an angle, so I create a revolving contour. Good. In this plane, F7, we create a line from this midpoint or from this. Yes. Up to the mid, right, down, right, and back. This line must be coincident with the center point or contain the center point. This must be center line. Dimensions are 7 and 15. On the other direction, again 7 and 5. Fully constrained. Finish sketch, revolve, cut. Okay. You see? Good. Now we apply fillets, which are 2 millimeters inside this and 3 millimeters on the other edges. Okay, let's apply. Two. By default 2 is here and here and on the back, plus this is 3 and also this is 3 and this is also 3. Okay, that's the part, my friends. The material is bronze, B, cast, which is this. Now properties, properties, physical update. You have here all the data if you want to model this part. I suppose you don't like how it looks compared with my first presentation. Let's make like this. We use something which was presented before, but I repeat for you. We select View, Default IBL, 2 lights, and then we make settings for that lights. I change the brightness to be at the maximum, and also the ambience. You see now it is more light. I move the cursor for the first light about here, and the other I select better light. The next one must be white, not gray, with position some like this, and I add a light 3. Yes, why not? If we can, we apply. This is its position, and here about we can add a 4th light, which can be yellow. Yes, and placed somewhere here and here. Now I apply some changes of the surfaces, making them with aspect. I select Autodesk Appearance Library because I have a lot of appearances. Bronze polished, and so I do with some other. This one, and the chamfer, this face, internal, these 2 faces, inside, back on this face and this face, and the last is this. I keep pressed the key Shift during this selection, and now polished for all. Oh, there is another. Here is steps. Here are the steps the name of this part is with step, and they must be also polished. To be like the part I presented at the beginning. You see, it looks just almost like this. You can move cursors in lights and you obtain anything you want. That's all for today. Thanks for watching. Bye bye.